Hello. Today I'm going to go over section 2.1. I'm going to go ahead and share my screen so you can see our OneNote and see and follow along. Now I will be posting these notes in Brightspace, but I will also provide them to you the next time I see you in class, and these are our Unit 2 notes. Our Unit 2 is actually looking at solving equations. And so first I want to make sure that we go over what's the difference between an expression versus an equation again, and to kind of talk about what we were able to do with expressions and how that differs from what we can do with equations. So in section 1.7, we looked at things like this, 3x plus 5. This is an example of an expression. There were two things that we could do. We could evaluate an expression when provided a value for x, or whatever the variable is. The other thing we could do is we could simplify it by combining like terms. So that is what we were able to do in 1.7, and I think we did a little bit of that in 1.2 as well with expressions. Now with equations, it's a little bit different. So first off, an equation is a statement that indicates two expressions are equal. Essentially, it'd be like saying 3x plus 5 equals 29. Okay, what it's saying is the quantity of 3x plus 5 is equivalent to the quantity of 29, essentially almost like a balanced scale. Okay, they have the same weight, the same value. The equal sign does not mean the answer is. Sorry for me kind of pointing that out, but when you're a kid and you do problems like 3 plus 2 equals and there's a blank, oftentimes you think of that as being like 3 plus 2, the answer is 5, but that's not actually what this means. It means that the quantity on one side is equal to the quantity on the other. If I were to simplify the expression now on the right-hand side, I end up getting 5 equals 5, which is true. The two sides are equivalent, and so therefore we have an equal equation. Okay. A solution to an equation is a value for the variable that makes the equation a true statement. So the first thing that we're going to do is we're going to actually take possible solutions and check to see if it actually is a solution or not. The way we do that in this example right here is you have your given equation, you have a possible solution, you substitute in that value for the variable, and then you verify that you get the same value on both sides of the equation. Now notice there's a little question mark over the equal sign. We do that because we're verifying whether or not it's true. We can't say it's equal until we know it's equal. Okay, so when you finish evaluating the left-hand side of this equation, you get that 11 equals 11, and so that is true. And so y equals 3 is a solution to this equation, okay, to this equation right here. So let's do an example. We're going to determine whether the given number is a solution to the equation. For A, the given equation is 4x plus 7 equals 5. We're checking if negative 1/2 is a solution. So we take our equation and we replace the variable with our possible solution. So we get 4 times negative 1/2 plus 7. Does that equal 5? That's why we put the question mark over it, because we don't know if it's true or not yet. We go ahead and put our 4 over 1. So that gives us negative 4/2 plus 7. Does that equal 5? Well, negative 4/2 is negative 2 plus 7. Does that equal 5? Well, we're just adding two numbers that have different signs. You can plug this side, negative 2 plus 7, into your calculator to get it, but also we know how to do this. We subtract the values and we keep the sign of what there's more of. So 7 minus 2 is 5. There were more positives, so it's positive 5 equals positive 5, which is true. So x equals negative 1/2 is a solution. It's a value for the variable that makes the equation true. This next one, our equation is negative 4 equals 6w minus 14. We're checking to see if w equals 3 is a solution. So we substitute it into the equation for the variable. So it becomes negative 4. Is that equal to 6 times 3 minus 14? We're going to evaluate, using order of operations, the right-hand side of this equation. And so that gives us 18 minus 14, because we do that multiplication first. Then we subtract. And again, we're checking to see if this is true. We get negative 4. Is that equal to positive 4? This is false. So W equals 3 is not a solution. So in this unit, you're trying to find the truth. That could be philosophical, but in this case, it's literally, can we find true statements? So the definition of a linear equation in one variable, right here, we have let A, B, and C be real numbers such that A is not equal to 0, because A equals 0 would cancel out the entire variable, so we can't have that. A linear equation in one variable is an equation that can be written in the form ax plus b equals c. That's like the example I gave at the beginning, 3x plus 5 equals 29. Okay, in this case, our 3 is our a, our b is 5, and our c is 29. Now, we could also have like 7x minus 2 equals 47. Okay, it doesn't have to be plus there, it could be minus. Also, it could be switched on the other side around. We could also have c equals ax plus b. Okay, or you could have it where the ax plus b are also switched. These are all the same thing. Okay, please note that a linear equation in one variable is also called a first degree equation because the variable x is to the first power. This is a throwback to the fact that anytime we see an x, it is assumed that it's being multiplied by 1 and raised to the first power. We don't write all of that because that would be redundant. So it's just a common convention that anytime you have an x, it's times 1 to the first power. Okay, that was a lot, but let's go on to start looking at these addition and subtraction properties of equality. This is just a fancy way of saying that these are the rules that we're allowed to use to try and figure out what an unknown value is. Okay, so essentially this property, if we read it, we have the addition and subtraction properties of equality. It's let A, B, and C represent algebraic expressions. The addition property of equality says if A equals B, then A plus C equals B plus C. Essentially, if I say 2 plus 3 equals 4 plus 1, this is true because both sides of the equation are equal to 5, so it's balanced. If I go ahead and take 2 plus 3 and add 5 to it, but I also add 5 to the other side, I've still kept this balance because now it's 10 equals 10. Okay, so the same thing happens with subtraction. If we have, we'll use the same numbers, 2 plus 3 equals 4 plus 1. That is true. So if I subtract the same thing from both sides, in this case, let's subtract, 1. We subtracted 1 from both sides, so now both sides would both be equal to 4. So we've kept the truth of the equation. So this is just a fancy way of saying you can add or subtract the same number or same value to both sides of the equation. And keep the equation balanced. Okay. The other thing to know is that addition and subtraction are considered inverse operations. Okay, meaning that they can undo each other. Okay, it's essentially like when we saw if I take two opposites and add them together, we get 0. Okay, so these inverse operations for addition and subtraction will always cancel to 0. That is what we were looking for. We want all addition and subtraction that happens to a variable to cancel to 0. Okay, so that we get our variable by itself. So that's kind of the name of the game. Okay, when we are asked to solve an equation, okay, what you are trying to do is you are trying to isolate the variable. Okay, to do this, you need to perform the opposite operations or inverse operations to undo the addition and subtraction. And we'll see that also will work with multiplication and division. And you need to keep the equation balanced. Meaning that whatever you do on the side with the variable, you have to do the same thing to the other side so that it will stay balanced. Okay, so just a quick check right now, making sure everything's on the up and up, looking good. Okay, going back to that. So we are going to solve what's called a couple of one-step equations. For example, 2a, b, and c. It's called a one-step equation because we can solve it in one step. Okay. So for the first one, we have x minus 7 equals 15. What I want to do here is look at the side that the variable's on, and I want to undo the operation that's happening to it. So on the side with the x, we have x minus 7. The opposite of minus 7 is adding 7. So I'm going to add 7 to both sides of the equation to keep it balanced. So on the left-hand side, minus 7 plus 7 cancels to 0. So I end up getting essentially x plus 0, which is just equal to x. And on the on the right-hand side, we get 15 plus 7, which is 22. You can always check your answer by plugging it in for the variable in the irregular or original equation and making sure we get a true statement. 22 minus 7, does that equal 15? I get 15 equals 15. So there is my confirmation that my answer is correct. Okay, my solution is valid. Because again, what we're looking for is the one number that would make this statement true. The only number that works for that is 22. Any other number, we want to get the same thing on both sides. And so the only solution to that equation is the only value that makes it true, which is 22. For B, I'm going to show the work a little bit differently on B, just because we're dealing with fractions. I'm going to show it the way that you will see it if you look at the examples in ALEKS. Essentially what happens is I'm going to still want to undo the operations that are happening to the variable. So I have x plus 1/8 equals negative 3/4. So I want to undo plus 1/8. So the opposite of plus 1/8 is minus 1/8. But what I do on one side, I have to do on the other to keep my equation balanced. So in this case, I'm going to switch to a different color for a moment. What ends up happening is positive 1/8 minus 1/8 cancels to 0, just like we wanted. So we get x plus 0, which is the same thing as just x, equals negative 3/4 minus 1/8. Well, I need to boost this. So those fractions from the first unit do not go away. Okay, so get really good at them. If you weren't already solid at them. I need to boost this so I have a common denominator. The common denominator in this case would be 8. So I get negative 6/8 minus 1/8. So we are adding or subtracting in this case with the same denominator. So I just perform the operation on the numerators. So we get x equals negative 7/8. Okay, we can check this by doing negative 7/8 plus 1/8. Is that equal to negative 3/4? Well, that would give me negative 6/8. Is that equal to negative 3/4? Well, this simplifies down to negative 3/4 because I could divide both sides by a fancy one that's over 2. So we get negative 3/4 equals negative 3/4. And so my solution, negative 7/8 equals x, is correct. With the last one, even though these are decimals, they're just numbers. We can do the same thing. The x, or the variable, is on the other side, which is perfectly fine because it's still just saying that these sides are equal to one another. They are balanced like a scale. Okay, so I'm still trying to undo all of the things that are happening to the x or whatever your variable is by using the opposite operation. So the opposite of plus 2.8 is minus 2.8. What I do on one side, I got to do on the other. These will cancel to 0, which is always what we're looking for, just like we did here. And so we get negative 1.1 equals x. You could rewrite it as x equals negative 1.1 if you like to write it that way better. These are the same thing. Okay, now you could perform this operation right here using your calculator. Okay, you would just type in 1.7 minus 2.8. All right, so you can check your answer. I'm not going to go ahead and show that because we've already seen a couple where we've done that, but you would just plug in the value and make sure we get a true statement. So I will leave that for you to verify. All right, these next examples, okay, they look more complicated, but the reality is we just have to kind of clean up our expressions on each side by combining our like terms. So on the right hand side, we just have two constants. 19 minus 3 is 16. And then on the left hand side, we have a couple of terms that both have x's in them. So negative 43x plus 44x is positive x, and I still have that minus 7 out in the front that I need to bring down. So now this has become just another one-step problem. I just had to combine both like terms on both sides first, okay? And so then here, the opposite of negative 7, this is why I like to think of it that way, because I think of it, what's the opposite of negative 7? The opposite of negative 7 is positive 7, so I'm going to add 7 to both sides. So here, I may get x equals, what is that, 23? And then minus 7 plus 7 canceled to 0, which is why we only had an x left on that left-hand side. And that is our solution. When you check this one, which I'll ask for you to do on your own, plug it into the original. Because if you made a mistake with your combining like terms, you'll be able to catch it if you use the original. Okay? If you were to do it into the one where after you combine like terms that you combine like terms wrong, you'd be checking with the wrong equation. Okay, so please make sure when you check, you go ahead and plug it into the original equation you were given. And then also you can use your calculator to evaluate each side of the equation. So you would evaluate negative 7 minus 43 times 23 plus 44 times 23. And then you'll check, is that equal to 19 minus 3? And so you would do the 19 minus 3 as well. Okay, and verify that you get the same thing on both sides. You should go ahead and pause and then try E on your own, and then I will just provide the answer for you so that you can check with that. Okay, so after pausing, hopefully you've paused, worked out problem E. After you do that, you should check and get that the solution is x equals negative 3. The last little bit of this section, okay, is using the same kind of properties for multiplication and division. The only caveat with this is that our C value, or what we're doing to both sides, cannot be equal to 0. But it's essentially the same idea. You can multiply or divide both sides by the same number. And get and keep the equation balanced. Okay, I'm going to go ahead and kind of pause at this point and split this up into 2 separate videos. So please bear with me. Thank you so much.